Hi, Intro to Calc. This is 5.2, Day 4. This is our last day on 5.2. Use your understanding of area to find the total area and the net area for the following functions. So these are the phrases that we need to really pay attention to today. So we've been dealing a lot with area, but net area means that you can have positives and you can have negative areas. And then when you add them up, you get a net change. Whereas total area just considers every area to be positive, and so you just keep adding positive values. So you're still going to graph your function the way that it should be graphed. So 2 minus x has a y-intercept of 2, and then you go down 1 over 1, down 1 over 1, etc., all the way on the interval that they give to you. That's what this represents. And so we're dealing with the area here in this right triangle and the area in this right triangle. So I'm going to take a second and come up with these areas. The one here on the left is 1/2 times 6 times 6. So that's 18. And then the area here is 1/2 times 4 times 4 is equal to 8. So once you have those two areas, now you can answer both questions. The net area considers negatives, so this will be 18 minus 8 because that 8 is below the x-axis. So the net area is 10, whereas the total area just considers the positive values. So 18 plus 8 is 26. Number 2 is homework. Number 3 is also homework. Number 4, you've got 1, 2, 3 circles, and you can have to figure out the radii of these circles first. So from -5 to -8 is a distance of 3. So that first circle will have an area of pi times r squared is 9 pi. But because it's a semicircle, you divide by 2. So we have 9 pi over 2. And we also have another 9 pi over 2 for this piece, because it also has a radius of 3. The semicircle in the middle has a radius of 2. So that'll be a full circle of 4 pi, but you have to cut it in half. So that's 2 pi. And now we can answer both questions. So the net area will be negative 2 pi, because you've got this positive 9 pi over 2, but you're also subtracting 9 pi over 2, and then you have this area that's below, so that's going to be a negative 2 pi. And the total area will add all three of these areas up. So 9 pi over 2 plus 2 pi plus 9 pi over 2 ends up being 9 pi plus 2 pi is 11 pi. All right, number 5 is homework. Number 6 we're going to do together, and this is an application problem, and we're going to use our calculator to help us do this. The velocity of a train in feet per minute is given by this function right here. Find the displacement, also known as the net area, and the distance traveled, which is also known as the total area, of the train on the interval from 1 to 5. So displacement is considering both positive and negative velocities, and that's why this is a net area, because when you multiply feet per minute by minutes, you end up getting a unit of feet. So if you have positive feet and negative feet, that is your net, versus your distance traveled, its unit is also feet, but you don't worry about velocity, you worry about its speed, which doesn't take into any account the direction, so no positives, no negatives. It's just that you've actually moved, and if you keep moving, they just keep adding those distances up. So put t, that function, into y1. Double check that you are in radian mode. Okay, and now on our home screen, we're going to do two different calculations. And which is the net integral from 1 to 5 of 3x dx, and your distance traveled, which is your total area, will be so close to it, so close to the exact same thing. All this does is make all of your velocities positive first, and that way when you add up your rectangles, then you end up getting a positive number. So we just have to come up with what these values are in the calculator. Okay, so on our home screen, we're going to do math. Number 9 is the integral. It said FNINT, so function integration. We're integrating from 1 to 5. And we put our function into y1, so I just have to have y1 show up right here. So we go vars, y vars, function y1 of dx. Enter. You could also type in right here the -4 sine of 3x, but you've already done it in y1. This saves just a little bit of time. So 0.31 feet. And then we'll do this similar calculation. So math, function integration from 1 to 5. And you want to do absolute values first. So math, number, absolute value, y1, dx. We get 10.36 feet. And that should make sense that your distance traveled is longer than your displacement, because distance traveled, once again, does not worry about any negative values. It says that you're just dealing with speed for the time that the train is traveling. That's it for 5.2. Go back and do those homework questions, and I'll look in your binders to see if they're right.